Hello, space enthusiasts and curious minds alike. Welcome back to our channel. Today we're diving deep into a groundbreaking update from NASA. After 45 years in the vast silent expanse of space, Voyager 1 has made a discovery that has left scientists baffled and excited. So buckle up as we explore what this impossible discovery is and what it means for our understanding of the universe. NASA has just announced an incredible milestone. The Voyager 1 probe, a marvel of human engineering, has officially become the first man-made object to break through the boundaries of our solar system and venture into the vast unknown of interstellar space. The excitement among the engineers on the Voyager mission is palpable. They've been on edge as the probe began transmitting mysterious signals that have left them baffled for months. The story begins with the launch of the Delta rocket, which carried critical instruments aimed at uncovering hidden physics among the stars and galaxies. After an epic journey spanning 45 years and traversing over 11 billion miles, more than 18 billion kilometers, Voyager 1 has not only set an extraordinary record, but also made a startling discovery that NASA is now urgently discussing. What exactly did Voyager 1 find that's so astonishing? We're about to dive deep into this revelation. Stay with us as we uncover NASA's urgent message regarding Voyager 1's unbelievable find in interstellar space, a journey that started on a historic day, August 25, 2012. Despite being largely unnoticed by the wider public, this day marked a defining moment in space exploration history. As we stand at the frontier of human achievement with Voyager 1, join us in unraveling the secrets of the cosmos. NASA is truly enthralled by one of the most mysterious realms of the cosmos, interstellar space. This is not just any region, it's the vast, cold expanse between the stars, where the solar winds, those streams of intensely charged particles flung out from the sun's outer atmosphere, finally lose their sway over the environment. At the heliopause, a boundary as monumental as any on Earth, the sun's winds meet the stellar winds of other stars, marking a dramatic cosmic collision zone. It's in this exact region that Voyager 1, a spacecraft moving at a staggering speed of 37,000 miles per hour, or 325 million miles per year, has ventured, making it the first human-made object to breach this frontier. 6 years after Voyager 1's groundbreaking journey, its sibling, Voyager 2, followed suit, crossing into this boundary to explore the unknown. But what does this far, far away region really look like? Picture the heliosphere as a bullet-shaped bubble enveloping the sun. From its surface, the sun violently propels solar winds at about 1.79 million miles per hour. These intensely hot, charged particles burst into space, filling the void with a sea of ionized gas. This phenomenon, known as the heliosphere, represents the sun's far-reaching influence, a celestial force field that Voyager 1 has daringly surpassed to bring us unprecedented insights from the edge of interstellar space. As the solar winds, comprised of plasma, stream out from the sun, they eventually slow down and come to a halt upon meeting the denser and cooler interstellar space. This space is not empty but filled with particles that originated from stellar explosions some 15 million years ago. The heliopause marks this critical boundary of our solar system, serving as a cosmic border where our sun's influence ends and the vast interstellar domain begins. When the Voyager missions were launched in 1977, scientists initially believed this boundary was just beyond Jupiter, about 365 million miles from Earth. However, they were soon to discover that the sun's influence stretched much farther than they had imagined. One of Voyager 1's most astonishing revelations in interstellar space was the density of this interstellar medium. Data from the spacecraft showed that the particles here were denser than those in the outer reaches of the heliosphere. This measurement was made possible by the plasma wave science instrument aboard Voyager 1, which detects electron density by sensing the vibrations of plasma waves. Scientists had anticipated that crossing into interstellar space would be marked by a simple, distinct signal, a bleep. Instead, they found the boundary to be far more thick and complex than expected. This groundbreaking observation by Voyager 1 was later confirmed by its twin, Voyager 2, 6 years later, deepening our understanding of the vast cosmic sea that lies beyond our solar doorstep. When Voyager 2 crossed the boundary of our solar system, the scientists monitoring the mission faced a puzzle. The magnetic field data returned by Voyager 1 had set certain expectations. They were anticipating a noticeable shift where the sun's magnetic field clashed with the magnetic fields of interstellar space. However, they were in for a surprise when the spacecraft reported no changes in the direction of the magnetic fields. Meanwhile, Voyager 1 was grappling with its own dramatic challenges that threatened to end its historic journey. A memory problem. It's one thing for humans to forget things from day to day with little consequence, but when you're a spacecraft billions of miles away from Earth, a memory glitch can spell disaster. For Voyager 1, this could mean the last time NASA would hear from it. The space agency had been tirelessly working for months, troubleshooting the aging Explorer after it began transmitting unintelligible data, leading to a critical pause in the mission. As the dedicated team at NASA delved into the intricate scientific work supported by Voyager 1, their main challenge was diagnosing an elusive glitch. The maintenance team focused their efforts on the spacecraft's flight subsystem, the crucial computer unit responsible for instructing the telemetry modulation unit to send data back to Earth. Early in their investigation, they zeroed in on a likely suspect, a single faulty chip within a component known as the FDS. A pivotal moment came when NASA engineers sent a command that coaxed Voyager 1 into transmitting a readout of its FDS memory. The findings were telling. Approximately 3% of the FDS memory was corrupted, hampering the computer's ability to function efficiently. The complexity of the issue is compounded by the sheer age of the technology. Most devices we use on Earth are not designed to last more than a few decades, let alone over 50 years in the extreme conditions of space. The fact that these machines are still operational is nothing short of miraculous. Moreover, the original engineers who constructed Voyager 1 have long since retired or moved on, adding another layer of difficulty to the troubleshooting process. And the vast distance, over 15 billion miles from Earth, further complicates the diagnostic efforts, challenging the team to solve a puzzle set in the depths of space, where every signal takes hours to travel back to our planet. Imagine sending a message to Voyager 1, nestled deep in the cosmos. It takes a staggering 5 hours for the signal to reach the spacecraft, and just as long for a response to travel back to Earth. This is akin to having a conversation where each person can utter only a single word per day. Engineers at NASA describe this painstaking process as troubleshooting in slow motion, turning their work into a series of educated guesses as they cannot pinpoint issues with immediate clarity. The prevailing theory is that the problematic chip may have been struck by a high-energy particle from space, or simply succumbed to wear after more than 45 years in the harsh environment of space. Adding to the frustration, the spacecraft is unable to correctly send messages back to Earth despite functioning as well as can be expected under the circumstances. Communication is crucially impaired, complicating the mission further. To tackle this latest crisis with Voyager 1, NASA even called upon a retired engineer, Bob Rasmussen. Starting his career just 2 years before the Voyagers launched, Rasmussen had been intimately involved with the mission for decades before retiring. Yet, the allure of helping to solve this cosmic puzzle brought him out of retirement, highlighting the ongoing passion and dedication that drives those who have devoted their lives to space exploration. Drawn back into the fold by the challenge of troubleshooting an old friend in deep space, engineer Bob Rasmussen re-entered the scene amid a communication breakdown with Voyager 1, a situation not unlike past dilemmas he had skillfully navigated. This time he committed to stay on, poised to tackle any forthcoming issues. Together with his colleagues, Rasmussen faced a daunting task to thoroughly reacquaint themselves with a spacecraft designed decades ago. Their job was arduous, involving the meticulous study of original design schematics, now yellowed documents adorned across various walls like relics of a bygone era. The engineers likened their work to archaeological excavation. Their diagnostic process was methodical, yet painfully slow. Commands were sent to Voyager 1 just once a week, typically dispatched on Fridays with responses awaited by Sunday. Progress trudged along, testing the team's patience, but their determination never wavered, not even among the senior leadership. The breakthrough they desperately needed arrived in March. Amidst routinely garbled communications, a clear string of numbers suddenly beamed back from Voyager 1. To the engineers, it was like deciphering the Rosetta Stone. One sharp-eyed engineer quickly decoded this newfound language, unlocking the secrets of the signals Voyager 1 now used to reach across the cosmic expanse, reconnecting Earth with its distant envoy. In the latest development, a crucial part of the response from Voyager 1 was traced back to the FDS memory. The team now faced a critical decision. Should they adapt to this new, corrupted mode of communication? Or could they possibly restore Voyager 1 to its pristine operational state? In the annals of space exploration, the Voyager missions hold a place of honor. When Voyager 1 and Voyager 2 set off on their groundbreaking journeys nearly 5 decades ago, few could have predicted that future generations of space scientists would still be gleaning valuable data from these trailblazers. Sponsored by NASA, these missions were initially tasked with exploring the outermost planets and the boundaries of the Sun's influence. Yet, over the years, they have dramatically expanded our understanding of the cosmos, venturing into realms once thought unreachable. Now let's cast our minds back to the launch period. John, I understand it was your decision to launch what was initially called Voyager 2 first, despite the naming confusion it caused among the press. This decision led to its historic departure from Cape Canaveral, Florida. This bold move set the stage for a series of discoveries that would rewrite our understanding of the solar system and beyond. On August 20th, 1977, a Titan Centaur rocket roared into the sky, marking the beginning of Voyager 2's monumental journey. Just 2 weeks later, on September 5th, 1977, Voyager 1 followed, launching on a faster, shorter trajectory that would allow it to reach its planetary targets ahead of its twin. Although they may now be overshadowed by more recent technological marvels, the Voyagers were wonders of their era. Packed with sophisticated equipment, these spacecraft were equipped to analyze, record, and transmit a wealth of data back to Earth. The instruments aboard the Voyagers were designed to study the atmospheres, magnetospheres, moons, and rings of the planets they encountered. This impressive suite included magnetometers, infrared and ultraviolet spectrometers, cosmic ray and charged particle detectors, and an advanced imaging system capable of sending back detailed photographs revealing the appearances of other planets in our solar system. In a move that still captures the imagination today, NASA included an intriguing payload on the spacecraft, a golden record. This record, packed with sounds and images, was designed to portray the essence of humanity to any potential extraterrestrial finders. A cosmic message in a bottle introducing humans as a species to the universe. Imagine an intelligence from beyond our world, encountering the Voyager spacecraft. This possibility shaped the initial trajectories of these pioneering vessels, which were the result of meticulous calculations. They were designed to seize a rare opportunity, a planetary alignment that occurs once every 175 years, allowing mission engineers to utilize gravity assists to dramatically increase the spacecraft's speeds and direct their journeys through the outer solar system. This innovative approach, revolutionary at the time, proved to be a spectacular success. Voyager 2 was set on a path that included flybys of Jupiter and Saturn, eventually making its way toward Uranus and Neptune. Voyager 1, on the other hand, took a sharp turn away from the ecliptic plane after its close encounter with Saturn, bringing it near Titan, Saturn's largest moon. Titan was of great interest to scientists because of its thick, nitrogen-rich atmosphere. After this encounter, Voyager 1 would alter its course significantly, setting its sights on its ultimate mission to exit the solar system and plunge into the vastness of interstellar space. Could the scientists of the 1970s, equipped with the technology of their time, really pull off such an ambitious mission? Or were they aiming too far beyond their reach? As the Voyagers embarked on their journeys, only time would tell if these bold aspirations would indeed become reality. The question loomed: how could the Voyager spacecraft continue traversing the cosmos for decades without running out of fuel? Voyager 1, much like its twin, wasn't built to sustain continuous thrust. Instead, its design focused on precise trajectory corrections and maintaining accurate orientation as it soared through the void of space. This sophisticated design enables the spacecraft to adeptly navigate and precisely align its instruments and antennas for optimal operation. Voyager 1 is equipped with a propulsion module that houses 16 hydrazine thrusters arranged in 2 sets of 8. One set is dedicated to controlling the spacecraft's attitude, while the other handles trajectory correction maneuvers. Hydrazine, stored in a central tank, is funneled through an intricate network of pipes to the thrusters. There, it reacts with a catalyst, breaking down into hot gases that are expelled to generate thrust. But what about the spacecraft's power needs over such an extended period? Here lies the secret to Voyager's exceptional endurance. Each spacecraft is powered by a radioisotope thermoelectric generator, or RTG. Notably, this power source doesn't rely on solar energy, a critical feature since the spacecraft ventures into regions of space where sunlight is scarce. The RTG's ability to convert heat from decaying plutonium into electricity has been the backbone of Voyager's power supply, enabling these distant messengers to continue their epic journey through the stars. As Voyager 1 ventured further from the sun, solar intensity became too weak to power its components. Instead, the spacecraft relies on a radioisotope thermoelectric generator, RTG, that converts heat from radioactive decay into electricity using thermocouples. These ingenious devices transform thermal energy into electrical energy, ensuring Voyager's systems remain operational. Voyager 1 carries 3 RTGs, each using plutonium-238 dioxide as the radioactive material. NASA selected plutonium-238 for its favorable half-life of 87.7 years, providing a steady and reliable heat source over extended periods. Initially, Voyager generated about 470 watts of electrical power. Although this output has decreased as the plutonium decays, the predictable rate of degradation allows NASA to manage the spacecraft's power efficiently. To conserve energy, NASA has systematically shut down instruments that are no longer essential. Among the first to be turned off were the cameras, as Voyager now travels through the dark expanse of space where visual imaging is no longer possible. This careful power management has enabled Voyager 1 to continue its historic journey, sending valuable data back to Earth even after more than 4 decades in space. Despite the challenges, Voyager 1's vital components are still operational, allowing NASA to continuously send and receive data and even upload updates to its operating system. This enduring functionality has provided an incredible return on investment in terms of scientific knowledge from the early stages of its interstellar journey. One of Voyager 1's most significant contributions came during its flyby of Jupiter, offering astronomers an unprecedented view of the giant planet. On March 4, 1979, Voyager 1 captured the first ever photos of rings around Jupiter, a discovery that astonished scientists. Before this, no one knew Jupiter had rings, debunking the notion that Saturn was the only ringed planet in our solar system. This thin, flat ring around Jupiter was just one of the groundbreaking findings. Voyager 1 also sent back a treasure trove of data about Jupiter's atmosphere. The images and information revealed complex cloud formations, swirling storms, and rapidly changing atmospheric patterns. Among these discoveries, one of the most iconic was the detailed observation of Jupiter's Great Red Spot, a massive, persistent storm larger than Earth. Voyager 1's journey has dramatically expanded our understanding of the cosmos, proving that even decades-old technology can continue to make remarkable discoveries. The Great Red Spot on Jupiter, a colossal storm larger than Earth, has been raging for centuries. Voyager 1 delivered stunning close-up images of this enormous cyclone, revealing its intricate wave-like structures. Through these observations, astronomers learned that the Great Red Spot rotates counterclockwise with a period equivalent to 6 Earth days. Voyager 1 also made the groundbreaking discovery of lightning in Jupiter's atmosphere. Before this, scientists didn't consider the possibility of lightning occurring on other planets. Voyager 1 revealed that Jupiter's thunderstorms are strikingly similar to those on Earth, formed by heat rising from the planet's interior. However, the lightning on Jupiter is far more frequent and intense than what we experience on our home planet. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos, and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together, we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.